Hello, 5.2. We are talking about zeros, which we've already kind of talked about. When we solved an equation, we found the zeros of the function, but we didn't always apply it. So first off, we have to be able to write in factored form. So first I'm looking to see, do they have anything in common? They do. I can take on an x, leaving with x squared minus 2x minus 15. And now I have to see if I can continually factor this, and I can. Two numbers that multiply to get negative 15 that we're going to add together to get negative 2 would be negative 5 and positive 3. So that's all I'm asking right here. I want you to pause the video and factor this next one. And now we can look, and this is factored. Now we're going to be graphing these by hand. I'm not going to care so much about the turning points. I care about what this graph looks like here. So first off, here, when we factor this, there's an x here, x and x. This has a degree of 3. So now I know what my end behavior would be because I have a degree of 3. Same thing here. I can look to see if I have 1x here, 1x here, 1x here. This means I have a degree of 3. I also can find the zeros in my function. I can set each one of these equal to 0. And if I set each one equal to 0, I get negative 2 here. I would add the 1 here. I would subtract or add the 3 there. So really, these are going to be where they cross the x-axis. So I can plot all 3 of these points. So negative 2, I have a positive 1, and a positive 3. If my degree is 3 and I do not have any negative in front here, that means my end behavior is going to be down, up somehow. Now, when I have points on the line, and I will show you different examples, but for right now, since these are our points, they only show one time. Each point I have to start down because my end behavior is down, up. On the left-hand side, I start down, and each time I go through each point. And now I have down, up. I'm not going to care so much about what's happened here and here. I'm going to be focusing to make sure that you have your points, your zeros correctly, and your end behavior. I want you to try to do B by yourself. So here should be your 3 points. I'm going to start down. I have to go through this point, and through this point. And it should look something like that. Now you could have the same answer. Like if I asked you this question instead, draw a rough sketch of this, and you had this as an answer instead, I would still count that because notice how the end behavior is still the same in both of the colors, and my zeros are still the same at those. So now I'm saying write this in standard form. Here are my zeros. I can write each one of these. So x minus 1 would be x plus 1, because if I were to move this over, if I have x equals 2, that would be x minus 2, because again, if I were to solve for x, I would add 2 over. If x equals 3, it would be x minus 3. So first I have to write it out into my binomials. Now it depends on how you want to do it. You can either multiply these two together and then multiply those together. I'm just going to start multiplying these together first. I'm going to do a parenthesis and then an x minus 3 so I do not forget that I also will have to multiply here. To multiply my first, I get x squared. X times negative 2 is negative 2x. 1 times x is 1x. 1 times negative 2 is negative 2. I can combine those like terms. So now I have a minus x minus 2. Now I have to multiply these two together. And you can do that in the same format that each one of these have to get multiplied. I personally, when I have a trinomial, so 3 terms times anything, I like to do it the box method just because it sets it to be more, so I don't forget to multiply 2 terms together. So when I multiply, the x minus 3 is here. Each one of these, notice how the subtraction and put the negative with it. So x cubed, this becomes negative x squared, negative x squared. This is a positive 3x, a negative 2x, and a positive 6. The other reason I like the box method is typically, not always, like terms are going to be diagonal to each other. So I would have an x cubed, negative x squared, plus, so you're adding inside the box, just like how you added each term here. Negative 3 minus 1x would give me negative 4x squared. 2x plus 3x would give me plus x plus 6. So this would be my final answer. I want you to try to do B by yourself. Now notice that there's 4 here, so this would be x plus 2, x plus 2, x minus 2, and x minus 3. I would suggest to multiply both of these together first, and then multiply the larger ones together. So first I multiply these two together, and I got this. Then I multiply these together and I got this. Then I did the box method. Again, I like how the diagonals are like terms. Notice how when I wrote this, I put a plus sign already, but this should be a negative. So I put just plus and negative, and that's fine too. So x to the fourth minus x cubed minus 10x squared plus 4x plus 24. I want you to try to do C and D by yourself right now. First, you might have noticed that these two are conjugate, same number, but opposite sign in between them. So the middle term cancels at x squared minus 9. Here, when I wrote this out, I already knew that this right here, these are conjugates, and I just multiplied it here. So these two together is x squared minus 9. And then I just distributed x times x squared gives me x cubed. X squared times negative 3 gives me negative 3x squared. X times negative 9, negative 9x, and negative 3 times negative 9. Now, multiplicity means when a 0 happens twice. So like right here, this 0 happened 2 times. So this has a multiplicity of 2. So I'm going to want you to write down these problems here. So again, write down those problems right there. There, it's a little better. So when I'm talking about multiplicity, I'm saying something happens more than once. So if something is squared, that means that 0 happens more than once. So we already know that we can solve this right here. So this is going to be x is equal to 2. But because this is squared, this has a multiplicity of 2 because it happens 2 times. This also has a x equals negative 1 because of this right here. That has a multiplicity of 1 because it only happens 1 time. I want you to go through to see if you can get the answers for the zeros and multiplicity of each one. So x equals negative 4 happens 1 time, negative 5 happens 3 times, positive 1 happens 1 time. X equals 0 happens 4 times, at negative 7 happens 1 time. X equals 3 happens 1 time, and negative 2 happens 2 times. Now the thing about multiplicity, you can figure out what your degree is of the overall. So if we were to multiply these all out, just like how we did up here, and it gives us our degree, your highest exponent, we can do that without actually even multiplying. So if you add up your multiplicities, this has a degree of 3. This right here will have a degree of 5. This has a degree of 5. This will have a degree of 3. And that's important for this next step because we're going to sketch the graph. So first, if it's not factored, you have to factor it. So I have x squared. This becomes x squared minus 8x plus 16. So this becomes x squared negative 4, so x minus 4, and that happens twice because x minus 4 times x minus 4 would be this factored. Again, this is x minus 4 times x minus 4. Okay, so now I can find my zeros. So x is going to be equal to 0, and that happens twice. And x is going to be equal to 4, and that happens twice. Now when I sketch this graph, the things I have to look for is my degree. So if I add these two together, my degree here will be 4. That helps me find my end behavior. Because this is even and it's positive, that means my end behavior is going to be up, up. Now, because this happens more than once, I'm going to put a star at both of these because that means it's going to look different on my graph. So when you are graphing this, I have x equals 0. So that's right here. I'm going to put a star there. And an x equals 4. 1, 2, 3, 4. I'm going to put a star there. So if I do this correctly, my end behavior should end up as up, up. If you have a point like we already talked about, you go right through the point. If it's a star, that means because it happens twice, it touches it and turns around. So if I'm going to start here on the left-hand side, I go to my first thing that is on my number line. So that's the star. Because it's a star, I touch it, I turn around. Somehow I'm going to have to try to touch this star as well. So I touch it and turn around. There's nothing else that's happening at my x-axis. So that would be the sketch of my graph. And that is it. Right now, I want you to find your zeros and your multiplicities of this first one. So I have a x equals negative 1/2 or 5/2 and x equals 3. So 1, 2, 3. Notice how this one has a multiplicity of 2, so I'm going to put a star there. And that's just for my mental, so I can remember, or my mental thinking, so I remember to turn around at that point. Negative 5/2 is the same thing as negative 2.5, so I'm going to put a point right there. My degree here is 3, so that means my end behavior is down, up. So I'm going to start down. Anytime there's a point, I have to go through that point. Anytime there's a star, turn around. If for some reason you're drawing a graph and you go through the x-axis at spots that you did not label, then that would be incorrect. I want you to try to do C and D by yourself. So this is what it looked like factor. So I have a 0 at 1, or a 0 at 0 one time, -3 one time, 3 at one time. So my degree is 3. That means my end behavior is down up. So I'm starting down. So again, anytime there's a point, I'm going to go through that point so it looks something like this. So this one's a little bit trickier because of this cubed. So if it's even right here, it bounces off, just like how we did there. If it's cubed or to the fifth, that means it just kind of has a little curve. So my end behavior is up. So I'm going to start up and go through that. So if I were just to focus it on this spot, that's going to look like a straight line. And then I'm going to have to turn, and then this kind of looks like a cubic, how it kind of has a little curve to it. And that's because of this 3, because that happened 3 times. There's a little curve there. So it doesn't look like a complete parabola. It does not look like a U. There's a little curve there because of that 3. I want you to try to do E and F by yourself. So you have 0, that happens 1 time, 8, that happens 2 times. So my degree here is 3, so it's down up. So I start down. I have to go through the point. Anytime I see a star, I have to touch it and turn around. So my end behavior is down, up. Here, my end behavior is down, up, but this happens 3 times. So again, it's not going to be a straight line. If you draw a straight line through this, that would be incorrect. A cubic has a little curve right at that spot. So it looks something like that. And there you go. Easy peasy, lemon squeezy. Have a great day.